So recently you have solved the theoretical question, and this is the solution of the coding problems that you have saw in the mock test part 1. Okay, in this video we'll talk about the solution, in-depth solution. So this video will be solution oriented. So please watch that part 1 to get an intuitive or a feel of mock test. Okay, now write a function that takes an integer n, okay, as an input and returns the sum of all prime numbers less than n. Okay, so let's say 10. So in 10 we have 1 2 3 4 5 6 7 8 9 10, and in that how many prime numbers we have? We have 2 3 6, not 6, 2 3 or 5 and 7 are the prime numbers. So in total you will get 2 plus 3 is 5, then 5 10 plus 7 17 as an output. Okay, so as we can see, the same case is written here. Now you can attempt this problem in multiple manners, but we'll talk the most optimal manner, which is sieve and anthosis pattern. Okay, the time complexity would be very optimal, like log of n, and how we can solve it, everything we'll discuss in this video. So now let's hop to the explanation. For solving this question, there is a very easy approach. It looks like sieve anthosis would be the great approach. It will be very hectic, but it is not. It is very easy. Let's see. In that particular approach, what you need to do is you need to create an array first. Okay, the array will look like this. Okay, great. So let me write it 0 1, okay, 2 3 4, then we have 5, then we have 6, then we have 7, then we have 8, then we have 9, then we have 10. So we need a correct n size of array so that we can find all the prime number lie in the range of n, and the approach should also be optimal one. Okay, so I have created an 10 size array. Now what I will do, I will fill each and every box with true. Okay, true, 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 then true, then true, then true, then true, then true, and then true. We have filled everything as true. Now the next step is, let me change the color so that it will be more intuitive or good. So yeah, what I will do, we know that the smallest prime number is 2, is it? So p denotes 2 here. So the number which is divisible by 2 cannot be the prime number. We know that. So what I will do, I will mark each and every number which is divisible by 2 by false. Okay, so 2 can't be because it's very small. So what I will do, I will mark 4 as false because 2, then we have 4, then we have 6, 4, 2 times 3 is 6, then we have 8, then we have 12, isn't, or 10, then we have 10, then we have 12, but we'll only check less than the range, and so 12 will be greater than the range, so we'll not consider 12. So 4, 6, 8 and 10 is marked as false because these numbers can't be the prime number. Now what I will do, I will increment my p so that yes, I have marked all the multiplicative of the number which is divisible by p to false. Now let's check with the rest of the numbers. Okay, I will go to the 3. Fantastic. So now I will check, do my square of 3 lies in the range? Because if it is greater than, if let's say p is equivalent to 4, or will come over that also. Okay, so p equivalent to 3. Now what all multiplicative of p is 3 are? So 3 is 3 times 2 is 6, then 3 times 3 is 9, then 3 times 4 is 12, then 3 so that much, because 12 is greater than range. Great. So 6 and 9 will be turned as false because this number can't become prime number. So yes, false. 6 is already marked as false and 9 is already marked as false. Now we'll again increment our p, but here what I will do is I will check, okay, 4 times 4 do is greater than the range. If it is greater than range, so there is no need of checking it, because it is hence proved that all the element is already marked as false, or whatever elements can't become prime is already marked as false if it is greater than the range. Okay, so I know that it definitely will be greater than or equal to the given n, so we'll stop it here. Our loop will stop it here, and this indirectly help you to find the range. And how it would be is, we know that from 2 from 2 to 10 we have a prime number sets. So what all number which is left as true will mark it as, or will count the sum of it. Okay, so what we have 2, okay, marked. Okay, then we have 3, okay, plus 3, whatever we have left 5, okay, plus 5, then again what is left 7, so plus 7. Anything else is true? No, it is not true. Then 2 plus 3 again 17, and see, is that the answer that we are looking for? Yes. Now 17. Now we got the intuitive logic behind the Steven enthusiast. Now how we can code it? It is a very easy approach, guys. What you need to do is, let's say you have a P counter with you. Great. Now simple as that, I will create a temp array like this. Okay, temp array which will marked as false, like true for everything. For everything it is marked as true, and till the length of n. Okay, it is a pseudo code. Not, don't think like I'm doing in some type of codes. Every code snippet you will find in the description. The GitHub link is there. In Python, C++ and Java, all three languages are present in that sheet. So just head over to that and look over the solution. But think about how you can write the code. So yeah, P equivalent to 2, fair enough. Then what I will do, I will check while my P times P is that less than equivalent to n. If it is less than, then we know that we need to mark all its multiplicative numbers to false, because those number can't become prime number, is it? So yeah, now I will check. Okay, it is less than, let's say 2 times 2 is 4, which is less than 10. So what I will do is I will check. Okay, temp, please go to the tooth location, and or go to the pth location and check whether it is marked as true already. If it is marked as true, which means we need to process their multiplicative numbers. Okay, so yes, now I will check. Yeah, it is true. Then I will create an integer I, which will take the square of it. Okay, because it can be the case like we stop at 6, and let's say we have did as p into 2, like 6 into 2 would be 12. So no need of marking the rest of the elements, because we know that if any time we found that the number is greater than the range, which means that the all prime numbers has been marked. So yeah, we'll check. Okay, I is equivalent to p into 2. So what I will do, I will do it as while my I is less than equivalent to the range, mark all the element, mark temp of I as false, mark all its multiplicative numbers as false, and just increment my I with 2 value, so that the all multiplicative number would be increased by twice, is it? So that every number would be done. So yeah, 4, then 3, then we have 6, then we have the stuffs like I plus P would be there, because I plus P, 2 plus 2 would be 4, then 4 plus 2 would be 8, because we have 2 is as P. Okay, now great. Now next step would be very easy. We just need to increment our P, so that continuously for every prime number we can check all these numbers. Great. So 2, 3 has been processed, then we'll come to 5, but will not process the 5 because it is already marked as 5. So when it comes to 4, it will check, okay, 4 is greater than 60, so will not consider it. Okay, so our loop will stop there itself. Yes, so this is our seam and enthusiast code. Moving forward, how to write this code? So as we are here on the file, so what you can do is just check it. Okay, the code link would be in the description. This is an Infosys question that we have created a sheet. From that only the Accenture has asked. And guys, this question is already asked by Accenture in their 9th of August shift. Okay, so yes, the solution you can find in Python, Java, as well as in C++. The link would be in the description. You just need to head over to this particular GitHub repository and look over the code. We'll not do it because we have already solved in the Infosys video also and in this Accenture video also. Now, without wasting time, let's see the second problem. Now, second question is a medium level lead code problem which was asked in previous year. That's why I took this question for mock. Okay. So given a matrix, print the given matrix in a spiral order. So spiral order, you need to print it. Now, what do you mean by spiral and stuffs? We'll see in the explanation. So you need to output like in this format. Okay. So let's hop over the explanation part. So spiral means, let me create a 3 cross 3 matrix for better explanation, is this. So this is a 3 cross 3 matrix. Okay. Now what happened is, let me write 1, 2, 3, then we have 4, then we have 5, then we have 6, then we have 7, 8, and 9 in our matrix. Okay. Now I need to print all the numbers in a spiral manner, which means firstly we need to traverse like this, so it will be printed as 1 2 3. Then we need to traverse like this, so again it would be like 6 and 9. Then again we need to traverse in this particular right to left, so it will become 8 and 7. Then we need to go upwards, so it becomes 4 now. Then again it would be repeated, so yes, it becomes 5. So this is the output of this particular answer. See how spirally we have did our particular traversal in the 2D matrix. So this similar stuff you need to write a code. And now you might be thinking, Aditya, this code is very hard, I don't know it. This is because you have not tackled the 2D or 3D 2D problem till now. But I am here and I will help you out to how you can solve this question in a very easy manner. Okay, so let me quickly remove this. So now see, what I will do in this particular question is, so I know that I need to process on the 4 directions, continuously 4 directions. What all direction? It would be like this, then this, then this, then this. So totally 4 directions we have. So for traversing on this particular matrix, you have n number of ways. Okay, but we will discuss only the optimal manner, because in the exam there are few things that you should think of is time complexity. So what I will do is I will mark few corners as this is as top, then this is as bottom. Okay, this is the bottom of my matrix and this is my top of my matrix. Fine enough. And this is the left side of my matrix and this is my right side of my matrix. Okay, now what is the next step, Aditya? So we have marked, so that we have given the computer his eyes. Now he can also visualize it. Great. Now computer knows, or we know, that we need to print in this direction first. So how we can print it? So let me write it. The direction 0 is we need to print in this manner. We need to print in this manner. Okay, which is, I can say that here what is changing? What is changing? Okay, we need to print this row. So row is constant here and the column is continuously changing. Okay, so what will be the print statement is, let's say this is the print statement of mat. Please, row is constant. So what is the pointer which is pointing to the current row, which is top, is it? So I know that top will remain constant throughout the for loop, is it? What will gonna change? Column will change. So firstly it will print 1 2 3 and it will stop at this point, is it? It will stop at this point. So now for direction 0, what we did, we have ran our for loop from top to the right side, is it? So this is the very first observation that we have found from this particular approach of first direction, is it? Now I know that, let me highlight it. So we have processed this much. Okay, so we have processed this much. Now what happen is, whatever thing you have made as constant, you just need to decrement that, because now top will again point to the same row which is processed already, which it is of no use. So now what you will do, you will increment your top and point it to the next row for the further operations. Okay, so I know that when I have traversed to top to right side, I need to increment my top. Fair enough. Now direction 1 is, direction 0 is done. Now direction 1 in this manner, we know that. Now in this manner, what is common? What is constant? I know that the constant will remain as right. Okay, because let me write 0 1 2 and 0 1 2. I know that the column will remain as 2, and what will gonna change? The row value will be gonna change. So now I need my too many of the pointer has been initialized. I need few pointers which will do this work for me. Now I can see that top is pointing to the correct row that we need to process. Is it? We need to process from 1 then 2, and the column remains same. So let me write it. What it becomes? Mat, the row will continuously changed here and column will remain constant. So constant value is already pointing by a right pointer, so there is not an issue. So we have marked that as right. So now we'll print it up. So it will print what? I become 1 firstly, then I will become 2 firstly, then we'll print 6 and 9 as well. As I have already said, is whatever thing that you have made constant, you just need to increment or reinitialize it. Okay, so right would be reinitialized to minus minus, because we need to shift our right from the second column to the first column. Great. Now, right is also being reinitialized. Now, I think till now we are going in a good manner. Okay, we have processed 2 directions. Now, the next direction that we have saw is this one. Is it? So now 8 and 7 we need to process. Now, how we can process it? So 8 and 7. So now for 8 and 7, I can see we need to go from right to left. Is it? So why don't you do it? So yeah, I will do it as print mat. What will be common here? I can see another pointer which is pointing to the exact row that we need. What is the pointer? No, the pointer is bottom. So yeah, so row will be constant throughout the for loop. What will gonna change? Column value will be changed from 1, then it becomes 0. Fair enough. So it becomes 0. Great. Now what happen is, here what is the value that you need to change now? See, we have processed this much. 8 has been printed and 7 has been printed. Now is there any use of keeping bottom at the same, pointing to the same row? Is that any use? No, it is not of any use. So what I will do, I will decrement my pointer to bottom to point at some new location. Okay, so that it will be used some other time. Great. So now bottom would be reduced here. Bottom would be reduced here and pointed to the next point. Fair enough. Great. Now, what I need to do it here is direction 4, which will go upside. Now, for upside, from where to where I need to put? Simple as that as direction 4 it is. We need to go from south to north. Now, bottom to top, as simple as that. So print bottom to top, and what at which element is currently focusing on and the row and the column that we need to go upside, which is, yes, left. I know, I have heard you have said yes. Mat of I know that it will change constantly because we need to go upward, so the row would be continuously changed, but the left pointer would be at the same location. Now I need to reinitialize because left is constant, and we know that whatever we are making as a constant, we need to change it. So yeah, left become plus plus. Now left would be shifted to this side, and bingo, success, you have successfully traversed the array spirally one time. Is it? Now you need to do continuously. Now if you want to do continuously, what you will do? You will do is, while my top is less than equivalent to bottom, okay, because if top overlap bottom, then it would be out of bound case, and my left pointer is less than equivalent to my right pointer. Till then, please repeat this particular operation continuously. But here we are also maintaining the direction. Is it? Direction also. So what I will do, direction plus 1, we need to do it every time. At every if condition executed, we need to increase our direction. Okay, so direction plus 1 mod 4, so that it will keep on under 4 directions. If we reach to 4, it will become again 0, then 1 2 3, then again it become 4, then it will again comes to 0. Okay, so continuously until we have not processed whole matrix, we'll do the same operation continuously. Okay, so this is the particular approach of this question. So this question is very easy and simulative type. When I will write the code of this question will look very easy for you. Is it? So let's see the code. So as you can see, this question was asked in multiple product based companies also. So let's tackle it. Okay, so we need rows. Okay, so rows, how we can fetch out from the matrix dot size will give us row. Fantastic. Now int columns, the column will give you matrix dot 0 dot size, it will give you the column value. Fine. Now What I need few pointers that we have discussed, is it? So in top, then int bottom, top is pointed to 0 and bottom will point to the last row. So we have pointed to the same. Now int columns. Okay, now int bottom is there. Now int left is equivalent to 0, and similarly int right we need, which will point to the last column value. Great. Now what happen is, column is done. Now we need a vector where we need to store the result also, as the question want us to return in a vector format, as we can see here. Okay, so in the exam it might be you need to print, so be careful at that time. Now similarly I need a direction also. I need a directions also, in which direction we are moving. This is the main case. Now starting the main code. Now while I know that my top is less than equivalent to bottom, I need to process this loop, and my left should always less than the right, then only I will process this array in a right manner. So I know that there would be 4 cases. What are the 4 cases? If my direction is 0, then I need to go from top to right. Is it top to right, as we have discussed in the approach as well? So let me copy it so that it will be more intuitive. Great. So, and the first direction one would go from where we need to come from top to right, top to right again. In the last we need to go top to bottom. Is it? So top to bottom we need to go, top to bottom we need to process. Fair enough. Then what we need to do is direction 2, in which we need to process from right to left. Okay, so let me write it right, then we write it right to left. Fair enough. Then in the last we have our direction 3, in which we need to go from bottom to top value. Is it? So pretty good question. Now what happen is, let me write the very first direction. So if my direction is equivalent to 0, in which I need to traverse from int I equivalent to 0, from I not equal, so where I is equivalent to top, and it I should always less than equivalent to right, because we need to traverse from left to right here. So I plus plus. So what is the case? What will remain constant here? What will remain constant here? Let me know, guys. Yes, top will remain constant because it is the row that we are pointing currently. So top and column will continuously changed, which will be continuously changed, and the first row element will be printed. And we know that top, please increment yourself and point to the new unprocessed row. Fair enough. So first direction is over. Very easy question, guys. Now the stuff is else if my direction is pointing to 1, then what I need to do, I need to go from top to bottom, making sense. So go from top to bottom. But here, what for which we need to process this particular row, is it with this particular column? So at this column, remember your explanation, what we have pointed? We have pointed the right as the column. And the last column is pointed by the right pointer. Great. And continuously we need to process our rows. Is it? So yeah, we have did the same. And if you have processed the right, please write decrement yourself so that you can process point to the unprocessed column. Okay, so now column right will point to 258 column. Fair enough. Now what I should do again is, else if my direction is equivalent to second, which is my third, where we need to go from right to left, where we need to go from right to left. Great. Now as we are going from right to left, so it would be decremented dead, and it should be greater than equivalent to left. Now what will be remain constant, guys? We need to print the very last row. Do you think bottom is pointing to the last row? Yes. And what will gonna change continuously? Column will continuously change. So we have it the same, and we'll tell bottom to please change your location and point to the unprocessed row. Is it? So row is also being processed. Now we came up to the very middle part, is the 3. Now we need to print 4 and 5. We need to print 4. Okay, then we need to continuously do the spiral formation again and again. Now for 4, we need to go from bottom to top. Is it? From bottom to top we need to go. Is it? So it will remain as same. And what will gonna change? Continuously row value will gonna change. And what is common? Remember guys, left is pointing to the very first column. And yes, we have used this similar stuff, and bingo, what I need to do is left, please increment yourself and point it to the unprocessed column. That's it. And in the last, what I need to do, I need to reinitialize my direction so that my direction will always remain in boundary. Okay, always remain in R4 direction. Don't exceed that. So yes, I think this will do our task, and our task is over. Let's run this code. So it is accepted. Now let's submit this code. So bingo guys, our code is submitted and the speed is 0 ms. So you can find the Python and Java code in the description, and all codes are working. So yes, please subscribe the channel if you have watched, and if you want a new mock test series, let me know. We'll create it and we'll publish it soon. So subscribe this channel, like this video, and share with your friends and batchmates so that they should do great stuffs in their career, and will meet you with a great content soon.